Hey guys, so today's lesson is going to be on just identifying parts of a parabola, and we're just going to focus on this problem that we see right here. And it was a warm-up that we did on the 24th. It was a Monday. So before we begin, let's just look at this equation and see what we notice about it. We see that it's y equals negative x squared plus 6x minus 9. Notice how I said the minus, inside, and the very first thing was negative. Anytime you're typing equations into a calculator, which is what we're going to do in a second, the first term, the very first thing, if it has a little minus sign, that's our negative. Everything else is just plus or minus after. So looking at this equation, we see that it's a negative x squared. And anytime you have an x squared that's negative, it's going to open downwards, meaning you're going to have an upside down u like that. And whenever you have an upside down u, you're going to have a point. Your vertex is going to be up top, meaning you're going to have a maximum. And if you don't believe me, that's quite alright. We're going to go ahead and plug that equation right into our calculator and look at it. So y equals, and like I said, it's negative x squared plus 6x minus 9. And I'm going to graph it just to kind of see what it looks like real quick. Alright, so it is an upside down u. It's opening downwards is how we would say it. And it looks like it's going to cross this x-axis at least one time. So I'm going to go to my table, second graph, and I'm going to go ahead and graph these points onto the table that's on my paper. So doing that, I see that when x is 0, my y is going to be a negative 9. And I'm just getting these points right off of my table on my calculator. When x is 1, our y is negative 4. When x is 2, you have negative 1. Here's 2, negative 1. When x is 3, you have 0. Then you have 1. Then you have negative 4. And when x is 6, you have negative 9 again. So I'm just going to go ahead and connect these dots. I'll move my hand out of the way so you can see it. There we go. So looking at this graph, we see that it does make a U shape and it does open down like we said, just like our graph did on our calculator. We see that it reaches a high point right there, and that after that point, it started to go down and everything kind of mirrored right after that. Meaning, if I went 2 to the left here, then I'm going to go 2 to the right over here. That's called our axis of symmetry. In symmetry, we use that, talking about when things are symmetrical, they are exactly the same, they match. And that's exactly what this line does. You see it referred to as line of symmetry, like in this worksheet, or axis of symmetry. So, for example, if I went from this line of symmetry to this point right here, our y-axis, or y-intercept, I went 1, 2, 3. So to find the other one, I would just go 1, 2, 3, and there's that point. So it cuts it in equal halves. Everything matches. You could kind of fold this paper over, and it would be right on top. So our vertex, now like I said, our vertex is either our highest point or our lowest point. In this case, we're talking about the maximum. And whenever we write our vertex, we write it as an ordered pair. So on the x-axis, it's at a positive 3. And on the y-axis, it's at 0. So 3, 0. Now your line of symmetry, which is what we were just talking about, always, no matter what, will always be x equals and then some number. Now that number is not just any number, it's a very important number. It pertains to our axis of symmetry and our vertex. They go right together. So you look at the x value, in this case it's 3, and that's what we write. These two go hand in hand. You can't have one without the other. Now your zeros, we also use roots instead of zeros. You could use x-intercepts, or you could use solutions. Now our x-intercepts, whenever we talk about x-intercepts, we know that our y must be 0. So I can go ahead and I see that this graph is going to touch one time and that I'm going to have a 0 in the y spot. So all I have left to do is find out what x value. So I look at it and in this case it's 3. Now I know the vertex and the 0 have the same ordered pair. That is just a coincidence. That does not always happen. It is possible to have one root like we have here, or the graph can cross twice, or it can't touch at all. So you have 3 options and you just got to look at the graph and kind of decide from there.